Welcome to this class. I am sure you must have seen this question most times in derivative and integration. You are asked to find the derivative of tan x or tan theta or whatever. And most times you say that d tan x dx is given as sec square x. So in this class, what we are intending to do is to find how this derivative is equal to sec square. So let's get started. What we do first of all is know that in trigonometric identity, it was stated that sine x all over cos x is equal to tan x. And this is proven from the complementary angles. So with this, we are going to start. So what I'm going to do is remove this tan x or substitute it with sine x over cos x. So we go by saying that y is equal to sine x all over cos x. Now, when we have this, now the next thing we are going to do is to apply quotient rule. Now, remember what quotient rule says. It has that v du minus u dv all dx all divided by v squared. All right. So the question now is, what are we going to call our v, and what am I going to call my u? And that determines what I'm going to have. Now, let's get started. The numerator must be smaller because I'm going to be expressing it. All right, so we are going to have that u is for the numerator and v is for the denominator. So I'm going to have that u is equal to sine x. Remember, I have done a derivative for sine x. So sine x is given as what? Du dx is equal to what? Cos x. So what I'm saying is, whenever you differentiate sine x, your answer is going to be cos x. Now, the next one, I'm going to call cos x to be v. So v, all right, so v is equal to cos x. Now, the x is going to be what? When you differentiate cos x, you will always have minus sine x. All right. Now, look at the model. I'm going to put all of them inside there, but if you check very well, I have v is cos, I have u is sine, then I have du dx, which is du dx, which is cos, I have the v dx, which is minus sine, and v square is going to be cos square. So let's put all of them inside this model. So my v goes with what? So I'm going to say now that dy dx is going to be v, my v is what? Cos x dot. Dot is just a multiplication. Du dx is what? Also cos x. Then minus, I'll put my minus. U, what is my u? My u is sine, I'll put my sine x dot. What is my dv dx? My dv dx is minus sine, put minus sine x. I need to cover in the bracket all over. What is my v? Cos, and that is this v. I'll say cos square x. You must be wondering, why do I write cos square x in trigonometry? Trigonometry is not the same thing as algebra. So you can't write cos x square. No, that's not the way to write it. You write it cos square x, and that is the same thing as v square. All right, so let's continue. The next thing we are going to do is cos x multiplied by cos x is going to be cos square x. Minus times minus is plus. And sine x multiplied by sine x is what? Sine square x all over cos square x. Now remember, in another trigonometric function or trigonometric identities, we say that sine square x plus cos square x is equal to 1. So remember, it's commutative. Cos can come first and sine can come first. It doesn't matter which one comes, but the two of them will add together to give you 1. In that case, I'm removing everything here. I'm putting 1 all over cos square x. Now, remember, in reciprocal trigonometric identities, we say that when you have 1 over cos x is something as, is not cosec, is going to be equal to sec x. Now, since is 1 all over cos square is going to be equal to sec square x, and that is my dy dx. Thank you for being part of this class. Remember, the best thing to do is very noble. Hit the subscription button, like this video, comment, and share to the people that need it. Have a nice day.